All right, so now we have some problems where we're going to be using the variables, and we're going to go ahead and actually set those up now. And these are acceleration problems, and so we're going to be needing the three equations that we use to solve acceleration problems. Those are on the formula sheet on the front of the test, but I'm just going to write them down where they might be useful at the top of the page here. So we have the following. We have the position equation, which is good. We have the velocity equation, and we have the equation that we use when we don't have time available. So we have a car that starts from rest and accelerates at a rate of 2 meters per second squared. We want to know where the car will be after 2 seconds. So let's actually write out every letter that we have. So we start at a position of 0. That's always an assumption. We don't know where we're going to end up. We know that 2 seconds of time pass. We know that it starts at a speed of 0 meters per second. And we don't know the final speed. So we want to know where the car will be after 2 seconds. Let's use the position equation. And then we put in our numbers. X is 1/2 times 2 times 2 squared plus 0 plus 0. And we wind up at the 4-meter mark. Now we want to know how fast it's going. Let's use V is AT plus V naught. When we put in our numbers, that's going to be 2 meters per second squared. I forgot to write that as one of the knowns here. So A is 2 meters per second squared times 2 seconds. And that gives us 4 meters per second. All right, I meant to say final here. We'll go ahead and fix that. So we have a toy car traveling 100 meters in 2 seconds, and we have its acceleration. Let's write out everything that we know. We assume it starts from a position of 0. It ends up 100 meters away. Its starting speed is 0 meters per second. And its final, actually we don't know its starting speed. That was actually one of the unknowns. So we have to be careful because it asks us what the initial velocity is, so we have to assume it wasn't starting from rest. Nor was its final velocity a given. We know the acceleration is 4 meters per second squared, and we're told that this happened over a time of 2 seconds. So let's try to get the initial velocity. We have x is 1/2 at squared plus v naught t plus x naught. So 100 is 1/2 times my acceleration of 4 times 2 seconds squared plus v naught times 2 plus 0. So 100 is, we have 2, so half of 4 is 2 times 2 squared is 8 plus 2 v naught. We subtract 8 from both sides, and we're going to get 92 is 2 times v naught. We'll divide both sides by 2, and that gives us v naught is 46 meters per second. So that's part A. Now for part B, we'll take a similar approach. V is AT plus v naught, meaning we'll use our unknowns and our knowns. So V is 4 times t plus 46. T is 2 seconds. So we have V is 4 times 2 plus 46. And so we end up getting a final velocity of 54 meters per second. So that's part B. All right. Now this is an interesting problem in that we've got two parts to it. Part B, little harder than what I'd want to put on your test. I'll be a little bit more explicit and clear about where things are. So we throw a ball up into the air at 20 meters per second, and we want to know how high it goes. So let's first, we know that x naught is 0. We know that v naught, the starting speed, is 20. Now when you reach the top of wherever you're going to and you throw something in the air, your speed is 0 meters per second because you stop for a split second before you turn around and hit the ground. The acceleration is -10 because that's a downward acceleration. We don't know the time it takes to go up into the air. And we don't know how high up it goes. So let's see what we can do. Since we don't have time for part A, I'll use this formula. So we have here 0 squared is 20 squared plus 2 times -10 times x minus 0. We're going to get 0 is 400 minus 20 times x. We'll subtract 400 from both sides. We'll get -400 is -20x. When we solve, we're going to end up getting that x is 20 meters high. Now let's figure out the time it takes to hit the ground. So here we go. For part B, I know that its initial position is 20 meters in the air. It ends up at 0. I don't know the time. Whoops. I don't know the time. I know the starting speed is 0. I don't know the final speed. And I know that my acceleration is -10 because it's going downwards. So let's actually use the formula right here. We have x equals 1/2 times -10 times t squared plus 0 plus x naught because v naught is 0. We'll get 0 is -5t squared plus 20. We end up getting -20 added to each side, so we're going to end up getting -20 is -5t squared. We'll divide both sides by -5, and so we're going to get 4 is t squared. T is 2 seconds. And that's part B. All right, so those are the kind of the shorter acceleration questions, and we'll do more in the next video.